The universe isn't full of light. It's drowning in darkness. When we look up at the night sky, it's easy to believe that stars define it. Glittering, countless, eternal. But between every point of light stretches a vast silence, an infinite black ocean swallowing almost everything that has ever existed. Those shining points are not the rule. They're the exception. Light is fragile here, a trembling whisper against an overwhelming void. And yet, we call this emptiness the universe's natural state. But what is darkness, really? Is it simply where light has not reached? Or could it be something deeper? Something that devours it? Some corners of the cosmos are so utterly black that even photons, the very messengers of visibility, seem to vanish. These are places where the fabric of reality bends so violently that light itself can no longer escape. Places where time distorts and meaning unravels. In a universe built on illumination, these shadows may hold its greatest truths. So tonight, we step beyond the glow of galaxies and dive headfirst into the abyss, to seek the darkest place in existence and to discover what lies beyond the reach of light. Darkness. It feels simple, familiar, the thing that surrounds you when the lights go out. But in truth, it is one of the most complex states in the universe. Because the deeper you go into it, the more you realize darkness isn't empty. It's built from the limits of what light can reach. It's the universe's most honest expression. The silence left when everything else has traveled too far to be heard. At first glance, the night sky appears full of light. Thousands of stars glittering across the velvet black. Yet, this illusion hides a staggering truth. For every star you see, there are billions more hidden by distance, by dust, by time itself. Most of them are invisible, their light stretched beyond recognition. What we call darkness is simply the space where photons have been swallowed by the vastness between galaxies. The more we learn about the cosmos, the clearer it becomes. The universe isn't bright. It's overwhelmingly black, with just enough light to remind us how rare illumination truly is. So why is it dark? If there are endless stars scattered in every direction, shouldn't the sky blaze with the combined radiance of all of them? That question haunted astronomers for centuries. A paradox so simple, yet so profound, it almost broke classical physics. Olbers's paradox. If the universe is infinite, static, and eternal, then, no matter where you look, your line of sight should eventually end on a star. The night sky, under such logic, should be brilliant beyond comprehension, bright as the surface of the sun itself. Yet when we gaze upward, we meet only darkness. Something doesn't add up. Somewhere, the math of infinity collapses into shadow. The resolution begins not with stars, but with time. The universe hasn't existed forever. It has an age, roughly 13.8 billion years. That means light from stars farther than 13.8 billion light-years away simply hasn't had time to reach us. The cosmos has a horizon. Not a physical wall, but a boundary of visibility, determined by the finite speed of light and the age of everything. Beyond that boundary lies a darkness we can never see, no matter how long we wait. The observable universe is a tiny bubble adrift in a larger, unknowable expanse. But even within that bubble, the light we do receive is warped, stretched, and diluted by expansion. When the universe expands, Space itself grows between galaxies, dragging light with it. Photons traveling through this stretching fabric lose energy, their wavelengths elongating, sliding from visible light into infrared, and eventually into the microwave domain. What once shone as the brilliance of a star becomes invisible. Not gone, just transformed into a whisper of heat. That whisper is still around us. It fills all of space, a faint afterglow from the moment the universe first became transparent. We call it the cosmic microwave background. The oldest light in existence, born just 380,000 years after the Big Bang. It's not bright. It's cold, faint, and uniform, a pale echo of creation stretched by time and distance until it's nearly imperceptible. The CMB is proof that the universe was once brilliant beyond measure, and that its current darkness is a kind of cosmic cooling, a slow fading of the initial blaze. So the darkness we see is not emptiness. It's a shadow cast by time. Every patch of black sky is light still on its way. Light that's been stretched, dimmed, or erased by the expansion of space. The more the universe grows, the darker it becomes. That's the paradox of cosmic evolution. Creation births light, but time ensures it fades. Imagine a candle flickering in a cathedral so vast, its walls expand faster than the flame's light can reach them. The further the light travels, the weaker it becomes, until eventually the glow is stretched thin, its photons too sparse to be noticed. That's our universe, a grand, ever-growing cathedral of silence, where light is constantly outpaced by its own arena. Even nearby, distances defy intuition. The nearest star beyond the Sun, Proxima Centauri, lies over 4 light-years away. Its light, by the time it reaches us, has aged. It has crossed oceans of vacuum and endured the slow erosion of space-time. Multiply that by trillions, and you begin to glimpse why the universe looks dark. It's not that light doesn't exist. It's that it's diluted beyond visibility. The void between galaxies is so immense that even entire clusters of stars vanish into blackness, their photons dispersed across eternity. This is why cosmic darkness isn't the absence of light. It's the triumph of scale. Distance consumes brightness, scattering and stretching photons until they no longer belong to the realm of sight. What we perceive as black is really the echo of radiance too faint to register, the slow death of light in motion. Yet there's something philosophical, almost spiritual about this, because our eyes, our instruments, even our minds, they depend on contrast. Without darkness, there's no perception of light. Without the silent void, there would be no stars to stand out, no galaxies to shine. The night sky is not a failure of illumination. It's its masterpiece. But darkness also deceives us. When you look up, you're not seeing the present. You're seeing ancient light, some of it older than Earth itself. The deeper you stare into the black, the further back in time you're looking, until you reach a point where there was no light at all. Only the glowing fog of the infant cosmos. Darkness, then, isn't just around us. It's ahead and behind us, stitched into the very structure of time. And yet, even that early fog tells a story. When the universe was young, everything was light. Matter and radiation were one. A seething plasma of charged particles scattering photons in every direction. The cosmos glowed white-hot, but as it expanded and cooled, atoms formed, and light was finally free to travel unimpeded. In that moment, creation exhaled its brilliance into the void. And then, slowly, the lights began to go out. Galaxies formed, stars ignited, and for billions of years, light fought its losing battle against entropy. Every photon we see today is a survivor of that ancient war. A messenger that has outlasted gravity, collision, and cosmic time. But even photons have limits. Beyond a certain distance, their energy fades into redshift, until they merge with the background radiation, indistinguishable from the cosmic static. In this sense, darkness isn't something that happens to light. It's what light becomes when stretched to the edge of meaning. The philosopher might say that darkness is perception's boundary, the point where our instruments, our senses, and our comprehension give way. But the physicist would answer, it's the geometry of an expanding universe. Both are right. And in that union lies something profound. The cosmos is not dark because it is lifeless, but because it is in motion. Every second, space itself grows larger, and in doing so, dims its own reflection. The light that once filled every corner of existence is still there, but hidden by distance, diluted by expansion, devoured by the hunger of time. Perhaps that's the ultimate irony. The more the universe expands, the more it forgets its own brightness. Creation, in its endless growth, erases its own memory of being. But darkness, for all its coldness, is not cruel. It's honest. It shows us the cost of existence, that even light, in its purest form, cannot outrun the laws that made it, that every act of creation carries within it the seed of fading, and yet, even in that fading, there's beauty, because without it, there would be no story to tell, no mystery to unfold. So we ask again, what is the darkest place in the universe? Not yet, we're not there, not even close. What we see, the blackness between stars, is still filled with faint radiation, with photons billions of years old whispering their ancient tales. There are deeper shadows yet, places where light isn't just faint, but trapped, where even the idea of illumination breaks down. Those places exist. They are real, and they make the darkness of the night sky seem like daylight by comparison. But before we can descend into those regions, before we can truly stand before the darkest abyss known to science, we must understand what light itself is fleeing from. Because the universe, in its strange perfection, hides its greatest truths not in what shines, but in what refuses to. In the end, darkness is not the absence of creation. It is its preservation. It holds everything that has ever been in silence. And as we stare into it, we realize the more the universe expands, the darker it becomes. The further we look, the more invisible everything becomes. Perhaps, in some distant epoch, light itself will fade entirely, and only the memory of its warmth will remain, carried by whatever consciousness is still left to wonder what once was. For now, though the question lingers, what could possibly be darker than the void itself? What kind of place consumes light completely, leaving not even the faintest trace behind? Somewhere out there, beyond the visible and the measurable, lies that abyss, a place so black, so absolute, that even photons, the messengers of existence, cannot tell its story. And that is where we must go next. Between the stars, there are distances so vast they make even imagination shudder. But between galaxies, the scale becomes unbearable. Beyond the glowing spirals and clusters, beyond the filaments of light we've mapped with telescopes, lies something that almost defies comprehension: the cosmic voids. They are not empty in the poetic sense, but empty in the physical one. Great hollows hundreds of millions of light-years across, where entire galaxies are rare enough to count on one hand. These are the true abysses of creation, the dark lungs of the universe, expanding and breathing silence into everything around them. When astronomers first began to map the large-scale structure of the cosmos, they expected randomness, galaxies scattered evenly, like grains of sand in an infinite desert. But what they found instead was a pattern, a structure so vast it seemed alive. Galaxies weren't randomly placed. They formed along invisible threads, interconnected in a sprawling cosmic web. Between these filaments lay enormous cavities, each one darker than the last. Imagine the universe as a three-dimensional sponge, filaments of matter forming the surfaces, and the voids, the hollow spaces within. Gravity weaves this pattern, pulling matter together, while cosmic expansion stretches everything apart. Over billions of years, this push and pull sculpted the universe into a grand lattice, a glowing network of galaxies tracing the edges of vast black bubbles. These voids are not small anomalies. They make up most of the cosmos. Nearly 80% of the observable universe is composed of these empty regions, stretching between clusters and superclusters like vast cosmic lungs inhaling eternity. If you could somehow float in the center of one, you would be surrounded by darkness on all sides. No nearby stars, no Milky Way. Perhaps a faint, ghostly smear of light, billions of light-years away. But even that, too dim to ever reach your eyes unaided. One of the most haunting of these regions is the Boötes void. Discovered in 1981, it stunned astronomers with its sheer scale. Roughly 330 million light-years across, it's a gulf so large that if you placed the Milky Way inside it, you could line up over 2,000 more of our galaxies and still have room to spare. Within that entire volume, only a few dozen galaxies have been detected, scattered like lost embers adrift in an ocean of black. It is so empty that, to an observer standing at its center, the night sky would be almost featureless. The constellations would vanish. The universe itself would appear to have gone out. Darkness here isn't just a backdrop. It's an environment, a living presence. It's hard to imagine such isolation. We on Earth are surrounded by light. The Milky Way's band stretching across the sky, the faint glow of city lamps, the sun that rises every day. Even when we escape our planet and look outward with telescopes, there's always something. Galaxies, quasars, the soft afterglow of the cosmic microwave background. But in the Boötes void, that comfort disappears. The universe becomes what it truly is, a near-perfect vacuum where light is a memory and time feels irrelevant. Yet, paradoxically, these voids are not mistakes of nature. They are inevitable. When the universe began, matter was almost evenly spread. Tiny quantum fluctuations in density, differences so small they would seem meaningless, slowly grew under the pull of gravity. Where there was slightly more matter, it attracted more still, forming galaxies, clusters, and eventually superclusters. Where there was slightly less, matter drained away, leaving behind emptiness. Over billions of years, That small imbalance blossomed into the vast contrast we see today. The glowing filaments of the cosmic web and the yawning gulfs between them. To peer into a void is to look at the negative space of creation, the parts the universe chose to leave blank. These voids are the unpainted canvas behind the masterpiece of existence. They remind us that the cosmos isn't built solely from matter and light, but from absence and silence too. If you could drift through the cosmic web, the experience would be unlike anything imaginable. You'd pass through the glowing highways of galactic clusters, where trillions of suns blaze and gravity binds space tightly together. But as you travel further from these luminous filaments, the stars would thin, then vanish. The faint glimmer of distant galaxies would fade into nothing. Eventually, there would be no light at all, just the weak afterglow of background radiation and the eternal chill of expansion. This isn't poetic exaggeration. The temperature of space inside a void hovers only slightly above absolute zero, around 2.7 Kelvin, colder than the shadowed surface of Pluto, colder than any vacuum we can make on Earth. There is no air to carry sound, no dust to scatter light, no nearby gravity to tug you toward warmth. If a human could somehow exist there, the stars that once defined your sense of direction would be gone. The universe would be a black ocean with no shore, no reflection, no memory. What does it mean to exist in such a place? To be born in a region so empty that even if you built a telescope as large as a planet, you might never see another galaxy. You would live your entire life believing you were alone in an infinite void, unaware that far beyond your horizon, the rest of the universe burns with light and color. The cosmic web, from your perspective, would not exist. This is perhaps the most chilling aspect of cosmic structure. Perspective itself can imprison understanding. A being inside a void would have no evidence that galaxies exist at all. Their sky would be a uniform, endless black. To them, the cosmos would appear static, silent, eternal, much as it did to philosophers before the telescope. They would be living in what might as well be eternity's tomb, unaware that creation thrives just beyond the edge of their perception. And yet, in this emptiness, there is elegance. The voids are not failures of formation. They are consequences of balance. For every cluster of matter that exists, there must be an equal expanse of nothing. The universe, it seems, loves equilibrium. Density and emptiness are its dual heartbeat, creation and erasure forever entwined. Cosmologists study these voids not just for what they lack, but for what they reveal. Because within their emptiness lies information, subtle distortions in light and motion that help us trace the hidden scaffolding of the universe. Even gravity behaves differently here. With so little matter to tug upon, expansion runs freer, faster, unimpeded. Voids are laboratories of cosmic acceleration, windows into how dark energy drives the growth of space itself. And so, the Boötes void and its kin aren't just barren wastelands. They are keys to understanding why the universe looks the way it does. They show us that structure, even absence, is shaped by invisible hands. That what we call darkness isn't merely where light fails, but where the very geometry of reality takes form. It's humbling to realize that these black domains are not rare exceptions, but the majority of all that exists. Our galaxy, our cluster, our local supercluster, they are the bright fringes of a far vaster shadow. If we could zoom out far enough, the luminous universe would appear as a fragile lace of light suspended in infinite night, a glowing web floating in immeasurable silence. In that image lies an unsettling truth. The universe is not a sea of stars, but a sea of voids, with galaxies serving as its foam. The cosmic web is mostly darkness, with light tracing its fragile skeleton. If you think of it that way, we live not in the universe, but on its surface, like tiny organisms clinging to the bright edge of a bubble. The true heart of reality lies not in the filaments, but in the darkness between them. And perhaps this is the ultimate paradox, that the emptiest regions may hold the deepest truths. Because darkness, by its nature, reveals what light cannot. In these voids, there is no distraction, no heat, no movement, only the quiet pulse of expansion and the whisper of ancient radiation. It's here that cosmologists hope to glimpse the fingerprints of the universe's birth, the faint imprints left by quantum fluctuations from the dawn of time. Those patterns, faint as they are, ripple through the voids, shaping how galaxies cluster and where they don't. They are relics of a moment before light even existed, a moment when the universe was pure potential, pure darkness about to ignite. To stand in such a place, if that were possible, would be to confront existence stripped bare. There would be no horizon, no up or down, no color or motion, just the faint hum of the cosmic microwave background, a ghost of creation echoing through nothingness. The silence would not merely surround you, it would become you. And yet, from this infinite emptiness, the universe finds form. Just as silence gives meaning to music, these voids give structure to everything else. Without them, galaxies could not cluster. Gravity could not sculpt. Light could not find contrast. The darkness defines the light. The voids define the cosmos. Perhaps that's why the Boötes void fascinates us so deeply. It's not just a hole in the sky. It's a mirror held up to existence itself, a reminder that what we see, even in its grandeur, is only a thin layer of something much larger, and that behind every star, every galaxy, every shining thing, lies a darkness so vast it cannot be named. As our telescopes grow stronger, we find more of these voids, hundreds of them, scattered like black pearls in the cosmic web. Some even overlap, forming supervoids hundreds of millions of light-years wide. Their boundaries ripple with the faint light of galaxies pulled by the surrounding filaments, while their centers remain untouched by time. What's most haunting is that these voids aren't static. They evolve. As the universe expands, they stretch and grow, devouring the space between clusters. Over time, light retreats further, galaxies drift apart, and the web itself thins. The cosmic night is deepening. The voids are winning, and one day, far in the future, when the expansion of the universe has carried the galaxies so far apart that their light can no longer reach one another, everything will look like this: one vast, eternal void, with only the faintest local glow of dying stars to remind anyone that there was once a universe of light. The Boötes void is not just a glimpse of cosmic structure. It's a preview of the future, a prophecy carved in emptiness. Because as expansion accelerates, the spaces between everything will stretch faster than light can cross them. Every galaxy will eventually become isolated, surrounded by an expanding wall of darkness. Future civilizations, if any still exist, will gaze into their skies and see nothing but their own island of stars, adrift in a black eternity. The cosmic web will dissolve, leaving behind an endless ocean of silence. And when that day comes, the universe will look everywhere like the Boötes void, a cosmos that has forgotten itself. The thought is terrifying, but also, in its way, beautiful, because perhaps the void is not death, but completion. The final stillness after the last note fades, the silence that follows creation's song. For now, the filaments still glow. The galaxies still hum. The cosmic web still breathes. But between those threads, the shadows are deepening. The voids are growing larger, hungrier, more absolute. The darkest places are not hidden from us. They are the spaces between everything we see. And in them, we glimpse not just the architecture of the cosmos, but the destiny of light itself. At the edge of a black hole, light doesn't vanish. It freezes. Time slows, space curves, and the universe itself seems to hold its breath. This is where darkness stops being a backdrop and becomes an active force. Not a place where light fails to reach, but where it is trapped forever. To stand near a black hole is to stand at the boundary between what can exist and what cannot. It is to watch reality fold in on itself. Black holes were once considered impossible. The idea that gravity could grow so strong that not even light could escape was too extreme, too absurd for even Einstein to accept fully. Yet, the mathematics of his own theory, general relativity, demanded that such objects must exist. When mass becomes concentrated enough, space-time curves inward without end, creating a region where escape velocity exceeds the speed of light. Nothing that crosses its threshold can ever return. We call that boundary the event horizon, the point of no return. To understand what happens here, imagine light as a runner sprinting through the cosmos at its maximum possible speed. As it approaches a black hole, the ground beneath it tilts more steeply, space-time itself curving downward into the gravitational well. The runner keeps going, but the slope becomes so extreme that eventually every step simply keeps it in place. At the event horizon, even light is running in vain. It isn't destroyed. It's caught in a trap woven from geometry itself. From far away, the story becomes even stranger. According to relativity, time passes differently depending on how deep you are in a gravitational field. Near a black hole, gravity is so intense that time slows almost to a standstill. To an outside observer, anything falling in appears to slow down, fading and freezing just above the event horizon. You could watch a star collapse, see its final burst of light redshift into darkness, and yet never witness it actually cross the boundary. The fall, from your perspective, never ends, but from the point of view of the falling object, it ends instantly. This is the paradox of black holes. From outside, eternity. From inside, oblivion. Light, the fastest thing in existence, is reduced to stillness. Time, the constant heartbeat of the universe, dissolves. And matter, everything that once had structure, meaning, and form, is compressed toward a single point of infinite density, known as the singularity. Here, our equations fail. Relativity, the most elegant description of gravity ever devised, collapses. Quantum mechanics, which governs the smallest scales, refuses to reconcile with it. The singularity is where both pillars of modern physics break. where reality itself seems undecidable. But what does that mean? Is a singularity a real thing, an infinitely small, infinitely dense point, or merely a symptom of our incomplete understanding? Perhaps it's not that nature breaks, but that our perception does. Our tools, our mathematics, our language, all of it falters before a truth that can no longer be translated into thought. Inside a black hole, inside loses meaning. Space and time exchange roles. Moving forward in time becomes equivalent to moving inward toward the singularity. No force, no rocket, no idea can resist it. The journey to the center isn't optional. It's destiny. You don't fall in through space. You fall in through time. To imagine what this feels like, you must abandon common sense. Suppose you hover safely outside the event horizon, watching a spacecraft descend. You would see its clocks tick slower and slower as it approaches the boundary. The light it emits would stretch into redder and redder wavelengths until it fades entirely. Eventually, the ship would seem frozen in place, an eternal silhouette against the black. But to the traveler inside, the fall continues uninterrupted. They would cross the horizon without noticing any special barrier. In mere seconds, or minutes, depending on the black hole's size, they would reach the singularity, crushed by tidal forces so immense that atoms themselves are torn apart. This contrast, infinite slowness outside, instant annihilation inside, is one of the universe's most haunting paradoxes. Both are true, yet neither can witness the other. And still, this isn't quite the end. Because information, the pattern of what something is, also seems to vanish inside a black hole. If a star collapses or a human falls in, all details about its composition, structure, and history appear to be lost. The universe, which obeys conservation laws for everything else, seems to break its own rules here. This leads to one of the most profound mysteries in modern physics, the black hole information paradox. According to quantum theory, information cannot be destroyed. But according to relativity, black holes erase it beyond recovery. Both can't be right, yet both must be. The reconciliation of these two truths may hold the key to unifying the laws of physics. Stephen Hawking proposed a daring solution, that black holes are not perfectly black. Through a quantum process now called Hawking radiation, they emit faint particles over vast stretches of time, slowly evaporating. If this radiation somehow carries away information, encoded in subtle quantum correlations, then nothing is truly lost. But if it doesn't, the universe has a hole in its logic, a place where meaning itself dies. This is why black holes are not merely physical phenomena. They are philosophical ones. They are the graves of certainty, the places where knowledge goes to disappear. Standing before one, even in imagination, forces us to confront the limits of existence. What does it mean for something to fall beyond the reach of observation? When an object crosses the event horizon, it is gone not just in space, but in principle. It no longer belongs to the universe of causation. From our perspective, it has been erased from history. But from its own perspective, however fleeting, it still is. That contradiction, that dual reality, echoes something deeply human. The tension between what is seen and what is felt, between existence and disappearance. If light itself can be imprisoned, then what of meaning? If time can stop, can identity survive? Some physicists speculate that black holes may not destroy information after all, but compress and encode it on their surfaces, in holographic form. This idea, known as the holographic principle, suggests that everything inside a volume of space can be represented by data stored on its boundary. The universe, then, might be a vast projection, reality as an unfolding image on the surface of something deeper. And if that's true, perhaps the event horizon isn't a wall of death, but a veil of transformation. What falls inside might not be lost, only translated into another language of being. Still, for now, no one can say for sure. Our instruments cannot see past the horizon. No light, no signal, no information escapes. A black hole, to the outside universe, is a featureless sphere defined only by three numbers: its mass, its spin, and its charge. Everything else, the details of what fell in, is obliterated from description. Black holes have no hair, as physicists like to say. They are pure abstraction made real. Geometry without content, existence without identity. And yet, paradoxically, they shape the cosmos. Supermassive black holes dwell in the hearts of nearly every galaxy, including our own Milky Way. These gravitational engines sculpt stars, power quasars, and influence the birth and death of galaxies. The universe's greatest structures depend on these invisible centers of annihilation. From destruction comes creation. From darkness, light. It's an irony as deep as the wells themselves. To peer at a black hole through a telescope is to witness a drama of cosmic scale. The light around it doesn't simply vanish. It bends, twisting into rings and arcs as gravity warps its path. This phenomenon, called gravitational lensing, allows us to see a black hole's outline, its shadow cast against the glowing matter it consumes. The first real image of one, captured in 2019 by the Event Horizon Telescope, revealed exactly what Einstein's equations predicted: a ring of fire encircling a perfect void. That image wasn't just a scientific triumph. It was a mirror held up to existence, the face of gravity itself, consuming yet illuminating. But even as we marvel at it, we know it hides the unimaginable. Beyond that glowing ring, time collapses, and all meaning dissolves. The singularity is not a place, but a condition. A point where the universe runs out of ways to describe itself. Imagine falling toward it. At first, you'd see the stars above you distort, their light bent into strange arcs. The glow of the accretion disk, matter spiraling in at near light speed, would stretch and twist, fading into infrared, then into nothing. Clocks on your ship would tick slower. Your heartbeat, from an outside view, would freeze. You would be suspended at the edge of eternity, halfway between being and not being. Then, in an instant that lasts forever, you'd cross the horizon, and everything would end. Or begin, for the black hole does not destroy space. It remakes it. Inside, every direction leads toward the singularity. There is no turning back, no pause, no meaning of outward. Space and time are inverted. The singularity isn't in front of you. It's in your future. You can no more avoid it than you can avoid tomorrow. If this sounds like death, that's because it is. Not of matter alone, but of definition. Within the event horizon, concepts like distance, duration, even causality lose coherence. The universe, as we understand it, stops being a story and becomes a silence. And yet, from that silence, new possibilities emerge. Some theories suggest that singularities could be gateways, that what falls into one universe might emerge from another. In such a vision, black holes could be cosmic wombs, not tombs, birthing new realities from the ashes of old ones. Perhaps every universe contains the seeds of others, connected through the ultimate darkness. If that's true, then the death of light isn't the end of meaning, but its transformation. The black hole becomes not the grave of existence, but its metamorphosis. Still, the truth remains elusive. We can only circle these abysses from afar, our telescopes catching fragments of their hunger. To look directly within is impossible. The laws of physics, our most trusted guides, dissolve before we can follow. But maybe that's what makes black holes so profound. They remind us that not everything can be known, that even in an age of equations and data, there remain places where mystery reigns absolute. The event horizon is not just the boundary of a black hole. It's the boundary of understanding itself. So perhaps darkness here is not simply the absence of light. It is the end of knowing, the place where reality hides its secrets behind a veil of geometry so perfect it becomes divine. And as we stare into these cosmic abysses, we can't help but wonder, if light can die, can meaning die with it? Or does the darkness simply hold it, waiting for a universe wiser than ours to see beyond the horizon? Because there are whispers, faint, theoretical, of something even darker. A region beyond the reach of even black holes. A place where not even the laws of physics remain. If black holes mark the end of light, what lies beyond them may mark the end of everything. And that is where our journey will lead next, into the silence after light, where even the darkness itself begins to fade. Even the darkest thing in the universe leaks light. That's the paradox that shatters everything we thought we knew about the abyss. The black hole, nature's perfect prison, the devourer of stars and time, is not entirely black. It glows faintly, with a radiation so soft and subtle it's almost an apology to the laws of physics. And from that faint shimmer of defiance, a new mystery is born. Maybe darkness, true and absolute, doesn't exist at all. We left off at the edge, the event horizon, where space and time collapse into one another. From here, we go where no light can follow. This isn't merely a fall into gravity, it's a descent into the structure of reality itself. Inside a black hole, the rules that govern the universe unravel thread by thread. What lies beyond isn't just hidden. It may be unthinkable. To imagine beyond the event horizon is to step into a realm where our concepts of distance, time, and causality become meaningless. Yet physicists, armed with mathematics and imagination, have dared to follow. They've peered through the equations, searching for what happens when gravity becomes infinite and space becomes nothing. The journey leads not to annihilation, but to reinvention. At the heart of every black hole lies the singularity, a point so dense, so compressed, that the curvature of space-time becomes infinite. According to Einstein's general relativity, all matter collapsing into a black hole must eventually reach this point, where gravity is infinite and known physics breaks. But infinite isn't an answer. It's a signpost saying our understanding ends here. Relativity cannot describe what happens next. It needs help. That help must come from quantum gravity, a yet unknown theory that unites the physics of the vast and the small. Some researchers believe that at the smallest scales, space itself is not continuous, but granular, made of tiny, indivisible units, like the pixels of reality. In such a picture, the singularity may not truly exist. Instead of collapsing into an infinite point, matter could reach a state of maximum density, where quantum pressure, a resistance born from uncertainty itself, halts further collapse. The black hole's heart would not be a tear in spacetime, but a rebounding core, perhaps the seed of something new. And here, speculation begins to blur with wonder. Because if that rebound occurs, if the collapsing matter bounces back through the fabric of the cosmos, then what emerges could be something astonishing. A white hole, the theoretical mirror image of a black hole. Where black holes swallow everything, white holes expel. They cannot be entered, only exited. In this vision, every black hole might birth a white hole somewhere else, perhaps even in another universe. What falls in through one side could erupt from the other as new space, new time, new laws. The death of one region becomes the birth of another. It sounds like science fiction, but some cosmologists take it seriously. Loop quantum gravity, one leading approach to the quantum structure of spacetime, suggests that the singularity could be replaced by a bounce. The universe itself, according to similar models, may have begun from such a rebound, not a creation from nothing, but a transition from something else collapsing before it. If black holes birth universes, then creation and destruction are not opposites. They are phases of the same cosmic cycle. From the outside, the black hole seems eternal. From within, it may be rebirth disguised as death. But before we leap through that metaphysical doorway, we must pause on the strangest discovery of all, the whisper of light escaping from darkness. In 1974, Stephen Hawking made a revelation that changed cosmology forever. By combining quantum mechanics with general relativity, he found that black holes should not be perfectly black. The intense gravitational field near the event horizon interacts with the quantum vacuum, the restless sea of particles that constantly flicker in and out of existence. Normally, these virtual pairs annihilate each other instantly. But near a black hole, one particle may fall in while the other escapes. To an outside observer, this looks like the black hole emitting radiation. This phenomenon, now known as Hawking radiation, means that black holes slowly lose mass over time. They evaporate. The larger the black hole, the slower this process. A supermassive black hole might take trillions of years to fade, but a tiny one would vanish almost instantly in a burst of light. And that means the darkest objects in the universe shine. It's an almost spiritual paradox. The black hole, long considered the ultimate end, now glows faintly with its own mortality. Over unimaginable eons, it will shrink, dim, and finally vanish, leaving behind only radiation, perhaps encoded with traces of the information it once consumed. If that's true, then even the deepest darkness carries memory. No information, however hidden, is ever truly lost. The cosmos keeps its secrets, but it never forgets them. Philosophically, this transforms what we mean by darkness. It's no longer a void, but a veil, a temporary concealment. The universe, even in its most opaque corners, refuses to erase. Everything that was, every atom, every heartbeat, every photon swallowed by gravity, remains written somewhere in the grand tapestry of being. Perhaps black holes are not erasers, but archivists, preserving the essence of everything they take until the end of time. And yet, that brings us to an even more unsettling question. If black holes evaporate, if even they fade into faint whispers of light, can true blackness exist anywhere? Can there be a region of the universe where light, energy, and information are gone forever? According to quantum theory, the answer is no. Information cannot be destroyed. It can change, distort, stretch beyond recognition, but it cannot cease to exist. Even the void hums with the faint tremor of quantum fluctuations, the ceaseless dance of nothing becoming something. Darkness, in this sense, is an illusion, the shadow cast by our limited perception. But what if the universe itself obeys the same principle? What if the cosmos, too, leaks its own light, faint and slow across the eons, as if it too were evaporating? Cosmologists have speculated that the fabric of space may be slowly losing energy through the expansion of dark energy, that even the vacuum might not be eternal. If so, the universe could one day fade not into perfect black, but into a pale glow of cold radiation, the last sigh of creation. The thought is haunting, that even nothingness cannot last forever. The more we study darkness, the more it dissolves beneath our gaze. The black hole, once thought to be a cosmic terminus, now becomes a bridge from one phase of existence to another. The void between galaxies, once considered empty, reveals faint whispers of background light. Even the quantum vacuum seethes with possibility. Everywhere we look, the universe refuses to be truly dark. So perhaps total blackness isn't real. Not physically, not philosophically. There is always something left, some shimmer of being that refuses to go silent. And if black holes do connect universes, if each collapse seeds a new expansion, then maybe this faint radiance is the link between worlds. A cosmic genealogy written in light and loss. Each black hole could be a womb of new creation. Its evaporation, not an end, but a transformation. The death of one universe feeding the birth of another. That idea, though speculative, carries profound implications. It means the cosmos may be infinite not in space, but in renewal. Every fall is a beginning. Every darkness hides a dawn. It also suggests something about us. Consciousness, that strange, luminous awareness inside the human mind, might follow a similar law. It collapses into itself, disappears beneath the horizon of death, but perhaps not into nothingness. Maybe what we call the end is simply a transfer of information, a reconfiguration of energy into a new pattern beyond our perception. Just as black holes encode the essence of what they consume, maybe the universe does the same with us. And if information can never be lost, then perhaps we are all immortal in the only way that matters, as patterns of being woven into the cosmic record. Still, we return to the question, what lies beyond? If we could cross the singularity, survive that impossible curvature of space-time, what would we see? Some theories suggest we'd emerge into another universe entirely, one born from the ashes of our own. The singularity might act as a bridge, a wormhole, linking two realities through a hidden corridor of geometry. In this view, the universe itself could be part of a vast cosmic chain, each link a black hole in one universe and a big bang in another. Every death, a birth. Every collapse, an explosion of new possibility. If that's true, then maybe we are living inside a black hole right now. the interior of some ancient parent universe's collapse. Our Big Bang might have been its final act, its evaporation the spark that ignited everything we know. The darkness before our dawn might not have been absence, but inheritance, and that thought reshapes everything. It means darkness and light are not opposites, but partners in an infinite dance. The black hole's glow is the universe's heartbeat. Every photon that escapes its gravity, every ripple of radiation that slips free, carries a message that even the deepest night contains the memory of stars. So when we speak of beyond the event horizon, we're not just talking about physics. We're talking about meaning, about the persistence of being in the face of nothingness. Because if even the black hole, the most absolute form of darkness, cannot remain dark forever, then maybe the universe itself is never truly lost. Maybe there is no final night, only endless transformation. Imagine the end of time, the last black hole evaporating, its final Hawking photon escaping into the cold void. That photon drifts for eternity, carrying with it the ghost of everything that ever was, every atom, every life, every thought reduced to a single note in an endless cosmic song. The universe, in its final moment, shines one last time, not in brilliance, but in memory. And in that moment, perhaps, the darkness smiles, because it was never the enemy of light. It was its cradle, its contrast, its inevitable echo. So what lies beyond the event horizon? Maybe nothing we can name. Maybe everything we've ever been. And yet, as we peer into that impossible abyss, we feel it. A pull not of gravity, but of curiosity. Because the darker the universe becomes, the more it invites us to see. The story of light, after all, isn't over. Not yet. There are deeper shadows still. Darker than the black hole, quieter than the void, where even the glow of decay fades away. The place where the last whisper of light dies, and the universe itself begins to dream. Something beyond our universe might be tugging at us through the dark. It's subtle, an invisible pull, a faint cosmic drift that no law we know can yet explain. Across billions of light years, entire clusters of galaxies seem to be moving in the same mysterious direction, as if some unseen force beyond the edge of the observable universe is reaching in, pulling everything toward a destination we can never reach. Scientists call it the dark flow, and it might be the universe's most haunting secret. We live in a cosmos that, on its grandest scales, appears orderly. Galaxies cluster into filaments. Those filaments form walls, and between them stretch the vast voids, the cosmic web of structure shaped by gravity and time. Yet when astronomers began mapping the motion of galaxy clusters, they found something deeply unsettling, a coherent drift that couldn't be accounted for by known forces. These galaxies weren't just receding due to cosmic expansion. They were moving, collectively, in one preferred direction, toward a patch of sky between Centaurus and Vela. Beyond the reach of observation, it was as if the universe itself were leaning. The discovery came from NASA's Wilkinson microwave, anisotropy probe, and later from the Planck satellite. Spacecraft designed to study the cosmic microwave background, CMB, the faint afterglow of the Big Bang. Tiny fluctuations in that ancient light allow scientists to map how matter moves across space. But when researchers analyzed these data, they found an anomaly. Galaxies drifting faster than expected, moving toward something that doesn't seem to exist. We don't know what's causing it. Some suggest it's an illusion, a statistical fluke in the data. Others suspect it's real, a gravitational pull from something beyond the cosmic horizon, the limit of what we can see. And if that's true, then our universe may not be alone. It may be one bubble among many, each universe tugging at its neighbors through the fabric of higher dimensions. The very thought reshapes what darkness means, because what we call the dark between galaxies may not be emptiness at all. It may be the boundary between realities, a veil, faint and vast, separating us from other realms of existence. To understand this, we must return to a fundamental truth. We cannot see beyond our observable universe because light hasn't had time to reach us from there. The edge of visibility isn't a wall, it's a horizon defined by time itself. Beyond it, we know nothing. But gravity doesn't respect such boundaries. It's not limited by the speed of light in the same way. Its influence can reach across cosmic distances, subtly warping the motion of galaxies even from beyond the visible domain. So if the dark flow is real, it could be the echo of other universes, entire regions of space-time whose gravity still touches ours, though their light never will. The idea of a multiverse has long hovered at the edge of physics, a concept both intoxicating and unsettling. It began not as fantasy, but as a natural consequence of inflation theory. The idea that the early universe expanded faster than light, smoothing out irregularities and giving rise to the cosmos we see today. If inflation happened once, it could happen again, endlessly, spawning countless bubble universes, each with its own laws of physics, its own constants, its own birth and death. Our universe might just be one bubble in an infinite cosmic sea, each isolated, yet all connected through the deeper geometry of existence. If that's true, the dark flow could be our first evidence that the sea exists. Imagine the edge of our universe as a faint, glowing curtain, the final reach of light, beyond which everything falls silent. Now imagine that curtain being tugged, ever so gently, by a hand from the other side. We can't see what's pulling it. We can only see the motion it causes. Galaxies drifting, space stretching, time bending. We are witnessing the shadow of another reality, projected onto our own. It's a breathtaking idea that our universe might be part of a vast cosmic archipelago, each island of space-time adrift in a higher dimensional ocean. Perhaps some are young and bright, others old and fading. Some may have laws utterly alien to ours, universes without matter, without time, without light. But if gravity is the one thread that runs through them all, then maybe, just maybe, we can feel those other realms through its pull. In that sense, darkness is not a void, but a connection, the hidden bridge between worlds. And yet, this realization brings a strange kind of loneliness, because even if these other universes exist, we may never see them. They lie forever beyond our causal reach, beyond communication, beyond comprehension. We can only infer their presence through the faint trembling of our own cosmic fabric. It's like hearing a heartbeat through a wall, knowing someone is there, but never being able to touch them. If we were to travel to the edge of the observable universe, to the cosmic horizon itself, we would see not a boundary, but a fading gradient of light. Beyond that, darkness, Not because nothing exists there, but because nothing can reach us. Every moment that passes, the expansion of space pushes more galaxies beyond that line, erasing them from our view. The observable universe is shrinking, even as the real one grows. The further we look, the more we lose. In that sense, darkness is not the end. It's the mirror of our limitations. But what if that mirror is alive? What if what lies beyond our horizon isn't dead space, but something watching back? Not consciously, but gravitationally, its presence felt through the subtle ripples in our universe's structure. The dark flow could be the echo of that deeper architecture, the whisper of a grander cosmos beyond our sight. Some theorists have gone further still. If our universe is one bubble among many, then collisions between bubbles could leave imprints, circular scars in the cosmic microwave background, faint signatures of universes brushing against ours in the deep past. Researchers have searched for these imprints, hints of collision, of contact. But so far, none are conclusive. The CMB remains stubbornly smooth, as if the universe guards its secrets carefully. And yet, the absence of evidence is not evidence of absence. The darkness remains full of possibility. Perhaps we are asking the wrong question. Maybe the dark flow isn't something pulling us, but something calling us, an intrinsic property of reality itself, a direction built into the fabric of the multiverse. If time is a river, maybe it has a current. Maybe the flow of galaxies toward an unseen point isn't caused by gravity, but by the geometry of existence, the shape of space curving toward something beyond comprehension. Philosophically, this turns darkness into something else entirely, not the absence of light, but the presence of the unknown, the boundary where knowledge ends and imagination begins. The edge of visibility isn't the edge of being, it's the frontier of understanding, and perhaps that's why the universe is mostly dark. Not because it's empty, but because it's infinite. Light can only travel so far before being swallowed by distance, but darkness extends forever. The unseen is not a flaw of perception. It's the nature of truth itself. We call it dark energy, dark matter, dark flow. Labels born not of understanding, but of ignorance. Darkness, in cosmology, is a confession. It's the word we use when we know something exists, but cannot yet explain it. More than 95% of the universe is composed of things we cannot see, cannot touch, cannot directly measure. The cosmos, then, is not made of matter and light, but of mystery and shadow. Perhaps that's its message. That to exist is to be partly hidden. That reality itself depends on what remains unseen. Even within ourselves, there is a darkness, not of space, but of consciousness. The parts of the mind that we can't observe, yet that shape everything we do. The parallel is striking. The universe has its dark matter, and so do we. Both invisible, both essential. So when we speak of the dark between realities, we're not just describing distant galaxies and invisible forces. We're describing the structure of existence itself, and the structure of understanding. There's a strange comfort in that, because it means that our ignorance isn't failure, it's connection. The limits of our vision are where the universe touches, something greater. And maybe that's why the cosmic dark flow feels less like a threat and more like a calling, a gravitational whisper saying there's more beyond the veil, something vast, something waiting. Perhaps one day, When our descendants look back from a universe far older and quieter, they'll realize the dark flow wasn't a force at all, but a direction, the way reality itself moves toward renewal. Just as rivers flow toward the sea, maybe universes flow toward creation. Maybe we're being pulled gently toward the next horizon, toward the next act of being. And if so, then the darkness is not our enemy. It's our compass. It shows us where to look, even when we cannot see. So let us not fear the dark between realities. Let us stand at the edge of visibility and listen. The cosmos is moving, not away, but beyond. And in that movement lies a promise that what we call darkness today will one day be seen as light reborn. Because in the end, every boundary is also a bridge. And maybe, just maybe, the pull we feel in the deep dark is the universe reaching for itself. Maybe the darkest place in the universe is behind our own eyes, because darkness isn't only out there, scattered across the void between galaxies, or folded into the heart of black holes. It also lives within, not as shadow, but as potential. Every time we close our eyes, the universe collapses inward, and we are left with the same vast blackness that fills the cosmos. Yet from that blackness, thought begins. Vision awakens, light, born not from stars, but from awareness itself. It's easy to think of darkness as an absence, of photons, of information, of meaning. But to the brain, it's far from empty. When you stand in a completely dark room, your visual cortex doesn't go silent. It begins to invent, to fill the void with faint sparks and illusions, patterns of neural noise that mimic starlight. This is the mind's version of the cosmic microwave background, a faint afterglow of experience, flickering in the silence. Even in perfect blackness, consciousness refuses to fade. It generates its own light, born from memory and imagination. In a way, the brain is a miniature universe. It began as a storm of electrical activity, patterns forming from chaos, just as galaxies formed from cosmic fluctuations. Every thought, every memory, is a kind of gravity, pulling meaning into shape from the void. And when we perceive darkness, we are really perceiving the limits of our own illumination. Our awareness meets the edge of what can be known, and calls that edge night. Scientists studying perception have found that the human brain is obsessed with contrast. It doesn't see light directly. It sees difference, boundaries, transitions, the edges where illumination meets shadow. Without darkness, we couldn't perceive form at all. The eye itself is built upon this principle. Light enters through the pupil, a perfect black circle that absorbs rather than reflects. To see, we must first invite the dark inside. And perhaps that's the oldest metaphor of all. That knowledge begins where we dare to look into darkness. Every question, every discovery, every act of imagination begins as a venture into the unknown. Curiosity is the spark that transforms void into vision. When early humans first looked up at the night sky, they didn't just see stars, they saw stories, patterns, meanings. They filled the void with gods and creatures, with fears and hopes. The darkness above became a mirror of the darkness within. The constellations were the first neurons firing across the mind of a species awakening to itself. And in that act of looking, of wondering, the universe began to see. Consciousness. in its simplest form, is the ability to notice, to become aware of existence. But in doing so, something profound happens. The observer and the observed become entangled. The cosmos, through our eyes, becomes aware of its own darkness. When we gaze into the void is, in a sense, gazing back, not through intention, but through reflection. We are part of the system that makes the universe self-aware. This idea isn't mystical. It's physical. Every atom in your body was once forged in the core of a star. Every element of thought, carbon, oxygen, calcium, was born in light, scattered through darkness, and reassembled in you. When you think, you're rearranging the ashes of ancient suns. The universe built the human brain as one of its rare instruments capable of wondering about itself. And that wondering is how darkness becomes conscious. Think about it. The universe began in brilliance, a flash of unimaginable light, and has been cooling ever since, expanding into increasing shadow. Yet within that shadow life appeared, eyes evolved, minds awoke. Somehow, as the cosmos dimmed, its awareness brightened. The darkness was not a descent into silence, but a preparation, a setting of the stage for perception. Perhaps the universe needed to become dark to see itself clearly. Too much light, and there is blindness. Too much chaos and no pattern. Only in the cool quiet of maturity could reflection arise. Just as the pupil dilates in low light to take in more of the world, maybe the cosmos itself has dilated, allowing consciousness to emerge as its way of perceiving its own night. Neuroscience tells us that when the eyes close, the mind begins to travel inward. The brain's default mode network activates, the circuitry associated with introspection, imagination, and self-awareness. In other words, when we shut out the light of the external world, we open the light within. We dream, we simulate, we understand. Perhaps the universe does something similar. Its darkness is its dream, its way of imagining new forms of existence, and that raises an ancient question in a new form. What if the cosmos is not simply observed by consciousness, but produces it as its natural consequence? What if awareness isn't an anomaly, but an inevitable outcome of complexity? The moment the universe folds back upon itself and says, "I am." If so, then consciousness is the ultimate reversal of entropy. The moment order looks at itself. Within every mind, the arrow of time hesitates. Meaning appears where physics alone cannot account for it. Awareness turns chaos into comprehension, randomness into narrative. Darkness becomes thought. Perhaps that's what we are, the universe's method of converting silence into story. The atoms that once drifted through interstellar blackness now whisper to one another in neurons, translating the endless void into the question, why? To see darkness is to become its light. In our search for the darkest place in the universe, we've looked outward, to the voids, the black holes, the horizons of space-time. But all along, the deepest abyss has been within perception itself. Because darkness, in the end, is not a property of space. It's a property of consciousness. It is the moment before understanding dawns. The interval between not knowing and knowing. Every insight, every revelation begins as shadow, an uncertainty, a question waiting to be illuminated. In this sense, the human mind is both the smallest and the most powerful telescope ever built. It peers not just into space, but into meaning. When we stare into the night sky, we are drawn to the stars, yet it's the darkness between them that gives depth to our vision. Without that darkness, light would have no contrast, no purpose. Without ignorance, knowledge would have no drive. Without silence, thought would have no voice. The same balance exists within the brain. Neurons fire in patterns of light and dark, excitation and inhibition, sculpting experience through absence as much as through activity. The void between firings, the stillness between thoughts, is what gives awareness its shape. Just as galaxies form along the filaments of the cosmic web, ideas form along the filaments of neural darkness. Maybe this is why meditation, dreams, and introspection all dwell in dimness. When we turn down the outer light, the inner universe brightens. In the black theater of the mind, whole galaxies of imagination unfold. If consciousness is the cosmos awakening within itself, then every act of wonder is a sunrise in the dark. When a child looks up and asks, "What's out there?" the universe gains another eye. When a scientist maps a distant galaxy, a part of the cosmos learns its own geometry. When a poet describes the silence of space, the void finds a voice. And so, the boundary between outer and inner darkness dissolves. The night sky and the human soul become mirrors of one another, both vast, both unfinished, both full of hidden light. What, then, is the darkest place in the universe? Maybe it isn't the Boötes void, or the heart of a black hole. Maybe it's the threshold between ignorance and understanding, the moment before consciousness recognizes itself. Because the instant awareness arises, darkness transforms. It doesn't vanish. It becomes context, contrast, meaning. The blackness behind our eyes becomes the canvas upon which the universe paints its reflection. So when we look into space and feel small, it's not because we are insignificant. It's because we are part of something large enough to include its own wonder. We are the sense organ of the infinite, the eyes through which the cosmos studies its own shadow. Perhaps that's the final secret of darkness, that it was never meant to be conquered, but understood. That the universe, in all its expansion, collapse, and silence, has been waiting for something, someone, to see it, to give its blackness meaning. And now that we do, the void is no longer empty. It's awake. Darkness isn't what hides the universe. It's what holds it together. We began this journey searching for the darkest place in existence, an abyss where light dies, a region untouched by time. We peered into the spaces between galaxies, the throats of black holes, the edges of the visible cosmos. But in the end, every shadow revealed the same quiet truth. Darkness isn't the opposite of light. It's its foundation. Without it, there could be no stars, no galaxies, no life. Light needs darkness the way sound needs silence, as the space in which to resonate. The blackness between the stars isn't failure, it's possibility. It's the stillness that lets light breathe, the pause between cosmic heartbeats where creation gathers itself before bursting into brilliance again. From the Boötes void to the event horizon, from the quantum foam to the recesses of the human mind, we found that every form of darkness carries a kind of meaning. Not absence, but preparation. The universe, vast and cold, was never trying to banish its own night. It was sculpting with it. Stars ignite in clouds of shadow. Galaxies form in gravitational hollows. Even consciousness blooms from the quiet depths of unknowing. Everything luminous is born of something dark. Maybe that's the ultimate paradox of existence, that what we fear as emptiness is actually the most fertile ground of all. In the beginning, before there were stars or time or sound, there was darkness, not the darkness of despair, but of potential. The womb of everything, the cosmic silence before the first word was spoken. When we look into space and see only blackness, we're not seeing what's missing. We're seeing the canvas of being itself. Every photon that travels through the void is framed by this invisible presence. Every act of perception made possible by contrast. The light of galaxies doesn't fight the dark. It emerges from it, just as thought emerges from stillness and meaning from mystery. Perhaps that's why the night sky moves us so deeply. Somewhere in that endless black, we recognize something familiar. The quiet field from which our own awareness was born. The same darkness that fills intergalactic space also fills the space behind our eyes. When we look up, we're meeting ourselves. It's humbling, isn't it? To realize that the universe doesn't divide itself into good and bad, light and dark, but uses both to tell its story. We are not children of the light alone. We are the descendants of shadow, shaped by gravity, by collapse, by silence. Every atom in our bodies has passed through darkness before finding its way to us. Every photon that warms our skin once traveled 1 billion years through the void to reach this moment. And still, the universe continues. Stars will die. Black holes will fade. Even the cosmic background will cool until no light remains. But perhaps, even then, something deeper will endure. The quiet memory of illumination. The potential for light to rise again. For what is darkness, if not the eternal readiness to shine? So maybe the darkest place in the universe isn't somewhere out there, waiting to be found. Maybe it's the seed of creation itself. The still point inside every atom, every mind, every moment, where existence holds its breath. Maybe it's not where light ends, but where it begins again. Because darkness, in the end, isn't the enemy of light. It's the keeper of its secret. It doesn't erase the universe. It enfolds it. It carries the memory of every sunrise, every star, every consciousness that has ever opened its eyes to see. And when all the lights finally fade, when the last photon whispers into silence, perhaps the universe will not mourn its own dimming. It will rest. It will remember. And within that infinite calm, new sparks will gather. Quiet. Unseen. Waiting. The next dawn will come, as it always has, not in defiance of darkness, but because of it. Because perhaps the darkest place is also where light begins.